When we think about pollution, we often picture smoke in the air or trash in rivers. But what if the most dangerous contamination was the kind we couldn't see underground? Groundwater is our invisible lifeline, supplying nearly 50% of the U.S. population's drinking water. Yet, this critical resource is increasingly at risk due to human activity in geology that can either trap or transport contaminants.
So what exactly is groundwater? It's the water stored in the tiny pores of soil, sand, and the rock beneath our feet. It's a natural reservoir known as an aquifer. As rain or melted snow sinks into the ground, it slowly fills these pore spaces. The two geologic properties that control how groundwater flows are porosity, how much water a material can hold, and permeability, or how easy that water can move. For example, gravel has high permeability, allowing water and pollutants to move quickly, while clay has low permeability, acting as a natural barrier. This difference is essential in understanding how contamination travels.
Groundwater contamination begins at the surface. Runoff from agriculture, industrial sites, and even urban roads carries pollutants like nitrates, heavy metals, and gasoline. These contaminants often originate from chemical weathering, like fertilizer nitrates dissolving into rainwater, or physical weathering, which breaks rocks into fine particles that hold or transmit pollutants. For example, acid rain accelerates the chemical breakdown of minerals, releasing harmful ions into soils that can seep into aquifers. One major issue is nitrate contamination from fertilizers. According to the EPA, over 20% of private wells in agricultural areas exceed the safe nitrate level of 10 milligrams per liter, posing risks of birth defects and certain cancers. Contaminants move down through soil into aquifers depending on the local geology. Once there, they can persist for decades and migrate miles from the original pollution area site.
The geology beneath us acts as both a filter and a highway. For instance, fractured bedrock in places like Storrs, Connecticut, allows pollutants to travel faster than in compact sediment layers. According to the 2021 article, A Comprehensive Review for Groundwater Contamination and Remediation, pollutants can migrate via both advection, following the natural groundwater flow, and diffusion, slowly spreading out over time. This process is especially problematic in over-extracted aquifers, where lowered water tables allow even deeper pollutants to spread. The study also highlights how fluoride, a naturally occurring contaminant, becomes harmful at high concentrations due to geologic interactions and poor regulation, especially in developing regions, but even in parts of the U.S.
Even here at UConn, groundwater monitoring wells track subsurface water quality. Past studies have shown how desossing salts used on roads and water infiltrate local aquifers, elevating chloride levels above background thresholds. This is a reminder that everyday actions such as salting sidewalks, using pesticides, even car washing, can affect systems beneath our feet.
Fortunately, solutions exist. One of the most effective is natural attenuation, where microbial activity and geologic filtering slowly clean the water. But this only works in the right geological settings. For example, aquifers with enough oxygen and low flow speeds. Where that's not enough, we rely on remediation techniques like pump and treat systems, bioremediation, and permeable reactive barriers. The article by Lee in 2021 reviews these methods and emphasizes combining them for long-term success. Still, prevention is the best strategy. We need policy and personal behavior to limit pollutants at the source, from improving agricultural practices to reducing household chemical waste. Climate change is also a growing concern. As glaciers retreat and snowpacks shrink, many regions are losing key sources of groundwater recharge. This reduces dilution of existing contaminants and can concentrate pollutants in aquifers, especially in areas already stressed by overuse or pollution. This is backed by a U.S. Geological Survey on groundwater information from 2023. Groundwater sustainability is no longer just a pollution issue, it's a climate resilience issue too.
Groundwater contamination isn't always dramatic, not just toxic spills or colorful fumes, but is one of the most persistent threats to human health and ecosystems. We walk over it every day, unaware of how fragile and vital this underground world is. Let's protect the water we can't see, because clean groundwater is not just an environmental issue, it's a life issue.